Okay, so they want me to state the domain and range of the function here. So if I look, the domain will be XER, and it goes from 1, 2, 3, 4, 5, so minus 5. It includes it, so there's an equal sign underneath. And it goes to 1, 2, 3, 4, 5 in the other direction, and again there's an equal sign because it includes it. The range goes from minus 4 to plus 3. Now we want to graph the inverse function, so we need two tables. So we need one for y is equal to f of x, and we need one for y is equal to f inverse of x. So I'm going to pick some key values. I'm going to read my graph left to right. So I have minus 5, minus 4. I have minus 2 and 3. 0, minus 1. I have 3, minus 2. And 5, 2. So all my y values will now become my x values. And all my x values will now become my y values. So now I'm going to graph that. So we have minus 1, 2, 3, 4, minus 1, 2, 3, 4, 5. One, two, three, 1, 2. Minus 1 and 0. Minus 1, 2, 1, 2, 3. And 1, 2. Okay, so this is f of x. This is f inverse of x. Okay, so it wants to know if the inverse is a function. It is not, because if I do my vertical line test, it goes through the graph twice. So is the inverse also a function? No, it is not a function. We want to state the domain and range of the inverse. So the domain goes from minus 4 to 3, and the range goes from minus 5 to 5. Well, very similar to what happened to yx and y switch, so that creates the inverse, so the domain and range would then also have to be switched between the original and the inverse. So we can say that the domain and the range switched. Well, what happens if we don't have a graph and we only have an equation? So f of x is the same thing as y. So I'm going to write it as y is equal to 4x minus 3. So what has been happening is that x and y have been switching. So I'm going to do the same thing with my equation. So my x and my y switch, and I resolve for y. And that will give me the inverse equation. So I now have x plus 3 is equal to 4y, and x plus 3 divided by 4 is equal to y. Then I need to state that that's the inverse, and I always have to do that. So I have to say that f inverse of x is equal to x plus 3 over 4. Or another way to state that is f inverse of x is equal to 1/4 x plus 3/4. Okay, same idea here. F of x is represented as y. Now I'm going to switch x and y, and I resolve for y. I do not want to square this. In squaring this, it makes a big mess. So I can complete the square to unsquare it, but it's already squared, so I'm going to leave it. I'm going to move the 3 over. Then I can take the square root. Remember, when you take the square root, there's always a plus minus. And then I can bring the 2 over and subtract. Again, I need to state that this is the inverse. And you can put the -2 in front, or you can put it on the end. If you put it on the end, just make sure it doesn't go under the square root.